Morning, everyone.
Good morning.
Hello.
Hey, Lindsay, can you hear me?
Yeah.
Were you in class yesterday?
No, my Wi-Fi wasn't really working.
Okay, because I couldn't remember if you came in or not, and I marked you absent, and I just want to make sure I was okay there. Okay, I just want to double check. Brooke, can you hear me? Are you in there, Brooke? I thought I let you in. Yeah.
Yes.
Hi, Brooke. I think I marked you absent yesterday as well. Were you here yesterday?
Yeah, I joined 2 minutes late, so that might have been what it was.
Okay, I'm sorry. I will fix that with attendance today.
No, it was my dad. My dad called me and he's like, "Did you skip?" And I said, "No, I didn't." And he's like, "What do you mean?" And I said, "I was definitely there." I said, "I might have showed up a little late though." And he's like, "Okay." He's like, "Well, then I'll just talk to the school because I have to talk to them anyways." I'm like, "Okay."
All right, I'll take care of it with the office today. I'm sorry. That was my fault.
No, I'm sorry.
No, don't be sorry. That happens. I mean, I get it. Not a big deal. I think we have like 2 more people here, so hang tight, guys. All right, so how did homework go yesterday? Okay?
Good.
Not a big deal?
I was
Good.
kind of confused on some of them.
Say that again?
I was kind of confused on a few of them.
On the which ones? Do you remember like what was happening?
It was like, hang on, let me pull back up.
That's
The
fine.
one that says find the measure of A, and it's like the x plus 53 and x plus like 83, and it gives you the one given angle of like 50.
Okay. I'm gonna pull it up too. I think I know which one you're talking about. Is it this one?
Yeah.
Okay. All right. So on this one here, you have your 3 angles. We know they have to add up to be 180 degrees, right? So I know 70 plus x plus 54 plus x plus 64 should equal 180. So if I combine my like terms, I have 2x, and I think it's 188, if I remember, if I add all my constants there. Yeah, 188. So, oops. Oh gosh, I'm out of control here. Hold on, guys. So we have 2x plus 188 equals 180. If I subtract 188, I end up with 2x equals -8. Divided by 2, I get x equals -4. So when I plug it back in for A, for angle A, so right here I have to use this expression. So it's going to be -4 plus 64 gives me 60 degrees. So that's why C is your answer.
Okay, that makes sense. Thank you.
Okay. I answered this one a lot yesterday. I don't know why this one threw everybody off, but I had talked about this one a lot yesterday. Any other questions from yesterday's homework? All right, today we're going to talk about what's called triangle inequalities. Okay, and this is helpful from the standpoint of when we start actually solving for side lengths of triangles and angle measures and that kind of stuff, like when we're solving for multiple parts, it helps us with the reasonableness of our answers. And I'll bring this back up later when we get to that. But it's kind of like the foundations of triangles, okay? Today's a lot faster than yesterday's. So here's our first conjecture or our theorem. It's called the triangle inequality theorem. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Okay, so it's saying no matter which two sides I add together, they always have to be more than the third side. Okay, so for instance, let's say I have 3, 4, and 5. That means that if this truly makes a triangle, then 3 plus 4 has to be greater than 5. 4 plus 5 has to be greater than 3. And 3 plus 5 has to be greater than 4. So I have to be able to combine any two sides to add up to be more than the third side. Here's why this is true. What if this was a 1? Well, I mean, and this is a 3. Okay, so if that's a 1, 3, and 5, if I just make up numbers here, the problem is if you think about actually measuring that out. So if that is 5 inches, and then I only measure 1 inch over, and then I measure 3 inches over, even if those sides were laying completely flat, they wouldn't even be able to touch, right? They would only stretch a total of those 4 inches, and there'd still be a gap. So what you need is those two sides have to be more than, just so that they can actually touch and then actually just pop up a little bit to make that triangle. So logically, does that make sense? Like the fact that they actually have to touch, so they have to be equal, but actually we needed a little bit more so that it pops up to be a triangle. Okay, so this is the actual theorem that you have to be able to test all of them. But logically, we could really just do one test. So if I call this A, B, and C, option A, B, and C, we really only need to do one of these. And it's going to be this one right here, because 5 is already bigger than 4, right? So, or 3 even. So 5 is already bigger than 3. I don't need to add anything else to it. 5 is already bigger than 4. I don't need to add anything else to it. It doesn't matter, right? And we can't have negative side lengths because it's a measurement. So if we just test the smallest two sides against the biggest side, if this is true, then it's going to be true for all of them. Okay, so for instance, if I had 7, 10, and 13. Okay, these are my two smallest. So 7 plus 10, is it greater than 13? Yes, it is. So it would make a triangle. If I had 2, 4, and 10. Okay, I really only need to check my smallest. 2 plus 4, is that greater than 10? No, it's not, because 8 is not greater than 10, right? So then it is not a triangle. It would not actually make a triangle. Questions about that idea? All right, so I'm going to give you a minute here. I have 4 different sets of measurements for a triangle. So this is going to be a yes or no. Does it form a triangle? So for each one of these, determine, will it form a triangle? I'm going to give you a minute here. Would anyone like more time? All right, So again, if we just check the smaller the numbers. So is 3 plus 7 greater than 8? Yes, so it does make a triangle because 10 is greater than 8. Okay, 3 plus 6, is that greater than 10? No, it's not. So this would not make a triangle because those two sides, 3 and 6, wouldn't reach all the way across even the expanse of 10, right? All right, so 4 plus 6, is that greater than 10? Be careful here because remember, it is greater than, not greater than or equal to, just greater than. So this is a no. This would not make a triangle. All right, the last one then, is 7 plus 7 greater than 7? Yes, it's 14. This one throws people off a lot. I think because they keep saying the same number over and over, they think 7 is not greater than 7. But keep in mind, this is an equilateral triangle, right? Because all sides are congruent. Questions on those 4? Okay, so now knowing that two sides have to be greater than the third side, I want to know if I give you 2 side lengths. Okay, so if I give you 2 side lengths, so if I give you the side lengths of 5 and 8, I want to know what are all the possible measurements for the third side. Okay, so we're going to think through this logically, and then we're going to kind of find a shortcut here. So I want to know all the different possible measurements for that third side. So keep in mind, we have 5, 8, and some unknown side, right? I don't know which one's the smallest, which one's the largest. So we have to think about all 3 of these sides. So if I think about my inequalities, 5 plus 8 has to be greater than x. Okay, so we know 2 sides have to be greater than the third. So let's think about all the different possibilities. I also know that 5 plus x, oh, that was an x, sorry. 5 plus x has to be greater than 8, and 8 plus x has to be greater than 5. Okay, now if I solve each one of these for x, okay, so algebraically, let's think about this. I know this says, if I do this one here, x is going to have to be less than 13, right? I have 13 is greater than x, but I'm going to flip it around and have x on the left side. Okay, if I solve this one here, I subtract 5 from both sides, I'd have x is greater than 3. Okay, this one, if I subtract 8 from both sides, I have x is greater than a negative 3. Okay, now, this answer here does not make any sense for us. Of course, it has to be greater than negative 3 because it's a measurement, right? And a measurement can't be a negative number. So I can ignore this. Because of the negative, I can ignore it. So now look what we have here. It says that x has to be greater than 3, but less than 13. So this is our compound inequality that tells me all the different possible side lengths for x. Okay, so x has to be between 3 and 13. It cannot be 3 and it cannot be 13, but it could be 3.00001. It'd be a really boring flat triangle, but it would work, right? Or it could be 12.9999999, but it can't be 13. So this is mathematically how that all works out. But looking at this box here, how do I get those numbers using these 3 without having to write out each inequality and having to solve each one? So using 5 and 8, we can even ignore the x. Using 5 and 8, how do I get these 2 values? So how did I get 3?
You subtract them. 5,
Yeah.
Or 8 minus 5 is
Good.
3.
8 minus 5 would give me 3. And to get the 13, I would add them. Right? So to get the lower bound, you subtract. To get the upper bound of that compound inequality, you add. That makes sense so far? All right, so think about this one then. My sides are 4 and 12. Okay, I know I need a compound inequality.
Greater than 8, but less than 16.
Good. You're gonna make it there? That was rough.
Oh,
right,
I thought
so-
I was muted.
Oh, you're good.
Sorry.
Oh, good. So I'm subtracting to get my lower bound, and I'm gonna add to get my upper bound. All right, in the comment box, put a Y if you're okay, put an N if you're not okay. Just so I can make sure everyone's alive and well here. All right, so I think we're good on that, right? Okay, so that's with triangle inequality. So in your homework, there's still more, so don't leave. In your homework, you're gonna have some problems that have like this. Give you 3 measurement, you answer yes or no, are they triangles? You're gonna have a few where you're writing the inequalities like this. And then you're gonna have a few where I give you, like if it's like 5 and 8, I list out a whole bunch of side measurements and I'm asking you, are those possible sides? Okay. The other part of triangle inequalities helps us figure out, this is where the reasonableness comes in. It's relating sides to angles. Okay, so in this figure here, X, oh geez, I just moved my thing. X here is opposite of this side length of 4. Z is opposite of side length of 3. Y is opposite the side length of 5. Okay, what happens is the largest angle is always opposite the largest side. The smallest angle is always opposite of the smallest side. The medium angle is always opposite of the medium side. Okay, so what that allows us to do then is figure out, if I give you 3 sides, I want to list the angles in order from smallest to largest. So if my smallest side is 10, then the angle opposite of that would be B. That would be my smallest angle. My medium side is my medium side is 13. So that's opposite of A. So that would go here. And then my largest side is opposite of C in this case. So C would be my largest angle. Okay, so whatever your side order is, in order of largest to smallest, that's also the opposite angles then are going to be in that same order. Any questions about that? All right, so this is going to help us in 1 second. So just kind of keep that in the back of your mind. We're going to flip-flop for a second to isosceles triangles. Okay, so we talked about isosceles triangles having at least 2 congruent sides, right? Those 2 congruent sides are called the legs. The non-congruent side is referred to as the base. The angles along the base are called base angles. And the angle between the 2 congruent sides is called the vertex angle. Okay, so it's important to know those terms there. They'll come back again. But here's where triangle inequalities help us. If the 2 legs are equal, then think about their angles. Remember how we just put them in order from smallest to largest? Well, if these 2 are exactly the same, then that means whatever the angles are, they're going to have to be exactly the same as well, right? Because of triangle inequalities. Okay, so if a triangle is isosceles, then the measures of its 2 base angles are congruent. So my guess is this idea of the base angles being congruent is not a new topic for you. It's not a new idea. It's my guess. But this is why, because of that triangle inequality. That's why they end up being the same. Okay, so when we end up having a problem like this, because I can see my 2 legs are congruent, that tells me my 2 base angles are congruent. So they have to be the same measure. And then I can use my skills from yesterday to solve for angle Y to get that this is 80 degrees. All right, any questions about any of that? What you're really going to be focusing on today is the triangle inequalities, like does it make a triangle? What side lengths could you have? And then there are questions about like which is the largest angle, which is the smallest angle, which is the longest side, which is the shortest side. Any questions for me? Okay, in Google Classroom, I have another Google form for you today. Sorry, we won't do another one this week. But this one was really nice and quick. That way you just click yes, no, make it faster. Okay, so go ahead and work on that, turn that in, and you're good to go.
See you, Mr.
All right.
Mingo.
Thank you.
Bye,
See ya.
have a good day.
Thank you.
Bye.
Bye, Mr. Ringo.
Bye, have a good day.
Have a good day.
Thank you, you too.